In this example, I need to solve the following system of equations using the elimination method, or it's sometimes called the addition method. Here is my system of equations, and what type of equations are these? Notice the highest exponent on any of the variables is a 1. So this is a system of two linear equations in two variables. And here are the steps for solving a system of two linear equations in two variables by the elimination or the addition method. Step 1 says write both of the equations in the form Ax plus By equals C. Well, looking at my equations, both of them are already in the form of Ax plus By equals C. So step 1 was already done for me. Before I go on any further, I'm going to label my equations. Here's equation 1, and here is equation 2. Step 2 says to multiply one or both equations by a non-zero constant so that the coefficients of the x's or the y's add to 0. In this case, the coefficient of the x's are slightly smaller than the coefficient of the y's, so I'm going to eliminate my x's, and I'm going to need the coefficient of the x's to add to 0. The best way to do that is to find the least common multiple of 3 and 2. That's the fancy way of saying what's the smallest number that both 3 and 2 will divide into. That's 6. So I'm going to need one of the coefficients to be a 6 and the other one to be a negative 6. Does it matter which one I make negative? No. So I am going to multiply equation 1 by negative 2. And that will give me negative 2 times 3x is negative 6x. Negative 2 times positive 4y is going to give me negative 8y equals negative 2 times positive 2 is negative 4. So now I have one of the coefficients as negative 6. So now I need a positive 6 for equation 2. So I'm going to have to multiply equation 2 by positive 3. And when I do that, 3 times 2x is positive 6x. 3 times positive 5y is plus 15y. Equals 3 times negative 1 is negative 3. So now I have completed step 2. Step 3 says add the new equations from step 2. So I just need to add these two equations. Negative 6x plus 6x adds up to 0, which is what I wanted. Negative 8y plus 15y is positive 7y. Equals negative 4 added to negative 3 is negative 7. So that is step 3. Step 4 says solve the resulting equation in one variable. That's fairly easy. Divide both sides by 7. These 7's reduce. I get y equals negative 7 divided by positive 7 equals negative 1. So I have solved the resulting equation in one variable. Now it says find the value of the other variable by back substitution. What that means is plug y equals negative 1 into either equation 1 or equation 2. It doesn't matter which one. I'm just going to plug it back into equation 1. So I am going to substitute, excuse the terrible handwriting, y equals negative 1 into equation 1. And what will I get? I'm going to get 3x plus 4 times y y is negative 1, so it's 4 times negative 1 equals positive 2. And this gives me 3x. 4 times negative 1 is negative 4, so I get 3x minus 4 equals positive 2. Solving for x, I'm going to add 4 to both sides. And I get 3x, negative 4 plus 4 is 0, equals 2 plus 4 is 6. Divide both sides by 3. And I get x equals 6 divided by 3 is 2. So now I have completed step 5, and the solution to this system is the ordered pair. Remember, x comes first, so it's 2, y is negative 1. So that is the solution to this system. Now, in step 6, it says that we can check the solution in both of the original equations. So I'm just going to check it very quickly. In equation 1, I have 3 times x. 3 times x is 2, plus 4 times y. 4 times y is negative 1, should equal positive 2. 3 times 2 is 6. 4 times negative 1 is negative 4. Does 6 minus 4 equal 2? Well, 6 minus 4 is 2. 2 equals 2. So I have a true statement for the first equation. You must also check it in the second equation. Does 2 times x, which is 2, plus 5 times y, and y is negative 1, that should equal negative 1. 2 times 2 is 4. 5 times negative 1 is negative 5, should equal negative 1. 4 minus 5 is negative 1. Does negative 1 equal negative 1? That is also a true statement. So I now know my solution is correct.